Welcome to Mathematics with Tom. I am Tom, and today we're going to be looking at section 2.1 in our book. It's titled Vectors and Linear Equations. And what we're going to do is we're going to look at the difference between the row solutions and the column solutions. And in our previous video, we looked at a two-dimensional example. In this one, I'm going to break a three-dimensional example and do my best to draw it for you. Let's begin. I need my chalk. So this is section 2.1, and it's called Vectors and Linear Equations. Here we go. We need some vectors, so I'm going to give you some vectors. How about this? Let, squished there, come down a bit. Let u be the vector 0, 0, 2. V will be the vector of, how about 1, 0, 2, 1, 0, 2. W, we need three vectors now. W is going to be 0, 2, 2. And we need one more, and how about B? B will be the vector 0, 2, 4. There we are. So this, if remember what this means. This means that B, vector B, is a linear combination. So linear combination of U, V, and W. Okay? So we can write this. This gives the matrix equation AX equals, we'll write our B in a moment, because A has the columns of A are the vectors U, V, W. Let's maybe sometimes just for clarity, it's U is the first column, V is the second, W will be our third column, times the vector x, or in other words, we would write this as 0, 0, 2, 1, 0, 2, 0, 2, 2, times x. Now, we'll write it this way. How about in the last picture, let's write it as, how about x1? No, let's use x, y, z. We'll let those be our scalars. And that matrix times this vector of scalars is equal to B, which is 0, 2, 0, 2, 4. Okay, and that is B. Okay, we're going to do, what we're going to do now is we're going to look at the row picture and we're going to look at the column picture. So here we go, rows. let's start with our rows. Need to leave myself some space. So what do the rows look like? Well, remember where the rows come from. The rows are a result of, you take the first row, which was 0, 1, 0, and it gets dotted with the vector of scalars x. So when we do that, we are going to get, let's do this. I'll show you. You're going to get a 0 times the x plus 1 times the y plus 0 times the z. Now, normally 0x, 0z we wouldn't write. I'm going to write them because I think it just helps to see the system of equations that are going to develop. So let's write that out. That's going to be 0x plus 1y plus 0z equals, and it has to equal the first component of b, that's 0 there, which is 0. Okay, then our next row is 0, 0, 2, and again we're going to dot that with x, our vector of scalars. So we write 0x plus 0y plus 2 times z. In this case, it's going to be 2. Okay, our last row is, it's a row of 2's. 2, 2, 2, and we're going to dot that with x. So that's going to give me my row of 2x plus 2y plus 2z is equal to, now our last component of b is 4, so this equals the 4. That's the row picture that we're going to work with. Now our column picture, our columns are just the scalars times the column. So remember, this as a linear combination would be written as x, the vector x, times the first column, which is 0, 0, 2. Plus, we're going to take some weight or some number of the second column, and the second column is 1, 0, 2, plus another scalar times our third column, which is 0, 0, 2, and somehow with the right choice of scalars, with the right choice of x, y, and z, we should get b, which is the vector 0, 2, 4. Now, you may see the solution, and that's fine, but let's see if we can actually see the solution by looking at it graphically. What are these two pictures? What are they showing us? Well, let's draw one at a time. So first we'll start with our row picture. So here's our row picture. And I'm going to have to scale this correctly. I think that's going to be a little big, so I'm going to need some space here to check my work. So how about, not like that. Probably wasn't any different, but oh well. Okay, so this is my x-axis, y, z, and we need to scale this. Oh, z is really crooked. Let's fix z so that it's straight. There, that looks better. There's z. And let's see, let's scale it like this. 1, 2, I don't know if I get 3, maybe 1, 2, and 3. 1, 2, 3. Okay, so here's my tick marks. Here's tick marks for the x-axis, tick marks on the y. And my tick marks for the z. Okay. Now, let's graph this. Remember, this is a three-dimensional picture. So the first picture says that I have 0x, 1y, 0 z's, and it equals 0. In other words, this is just the plane where y is 0. But x and z are free. They can be anything without affecting the solution. So here we go. I need some colors. I have some colors ready. And start with this pretty blue. So this pretty blue, we're going to use it. In other words, well, when y is 0, what we're getting is we're getting this. We're getting the xz plane. So it's just this plane here. So I'm going to just sketch that in. Okay, so I'm getting the xz plane. Now, that's our first one. Our next one, we're going to do another color. We'll do green. So our next one, notice that x and y are already zeros. This is that 2 times z is 2. Z is just 1. Well, z is 1 right here. Well, wait a minute. Oh, that's a plane. Essentially, the xy plane has just been moved up. It's like creating a new floor, a floor that's been raised up 1 unit. So I'm going to draw this like this. Try to keep my picture in the right alignment. Oops. So what is this? Now, really what happens is we have a new floor, so all of this is really going to be hidden underneath my second plane. So that'll be the green plane. So really now we've created a floor here. It's created this new floor, new XY plane. It's where Z is always 1 instead of always 0. So now we can't see through, if you imagine you couldn't see all the little blue back in here anymore. Now, all right, so we've got this next one. One more. This is probably a good one for pink. This one's hard. Let's start out by making both x and y 0. So in other words, we have 2 times z is 4, so z is 2. So let's see, x is 0, so I don't come out on the x. Y is 0, so I don't move on the y. Z is 2, so that's going to be 1, 2, I'm going to put a dot. Now let's repeat this. This time let's make x and z both 0. This says 2y is 4, y is 2. So we said that x is 0, y is 2, and z is 0, so we don't go up at all, so I'll put that dot there. And our last one would be y is 0, z is 0. This says that 2x is 4, x is 2. X is 2 would be 1, 2. Wow. Before I continue, let's look at what we have done. I'm going to use a different color to try to emphasize this. Notice that what we had here is we had the vertical plane, the xz plane in blue. And when we had a second equation here, we had a second plane. And they intersected right here where z is always 1. So the intersection of 2 planes right here is this line. It's an entire line of possible solutions at z is 1. So let's make a note of that. So this purple line here, this is the intersection of two planes is a line. In this case, it's a purple line. Yours could be blue or it could be green. Mine happened to be purple. Now we're to our last one. Well, let me come back. I put a dot here on the x-axis, a dot on the y-axis at 2, and a dot at the z-axis also at 2. So when I draw this, that pink dot there is actually under the green floor. The pink dot on the y-axis is also underneath the green floor. So not until you break through the green floor will you actually see our third plane. So I'm going to start with a little dashed line. Let's see if I can connect those in a straight format. So in other words, I'm going to just do dashes because it's behind the green plane, and then once it gets above the green plane, then we can see that portion of the plane. Further, the same idea applies here. When we start from the z on this xz plane, part of the plane, oops, I got my line going all over. Okay, so it's beneath the green floor here, so I'm going to use the dash, and then once it crosses the purple, it surfaces, it rises up, and where it crosses the purple, or in the green floor here and the green floor here, this right here, this is my third plane. Now, obviously it extends out further in all directions, but what I wanted to focus on was two things. First one is, notice again, the intersection of the green plane with my pink plane, again, is a line. The intersection of my pink plane with the blue plane is this line right here. The intersection of all three planes, well, we know is a point. Notice that in this case, if you have three distinct planes, that we know the answer has to lie somewhere on this purple line, and it looks like, if I've drawn this really well, it looks like the intersection right here is where z is 1, x is 1, y, there's no y there, so that'd be 0, and then up here at z is 1. That right there looks like my solution. So my solution looks like it's x is 1, y is 0, and I had to come up 1. That's what it looks like as my solution. So it's where the intersection of all of these planes, there's another line, here's another line, and where they all meet, that's my solution, right there. Okay, that's a lot of color, a lot of plane. I won't be drawing too many of those pictures. I would encourage you to try drawing some of these yourself. It's one thing to watch, it's another to draw it yourself. And I think as you draw some, you'll also begin to help to see the solutions. So that's our row picture. Oh, wait a minute. We need to check. Let's check. I wonder if I did it right. I could be wrong. Well, if I made a mistake, let's fix it. Let's check. So we're going to check our solution, 1, 0, 1, in each equation. So let's try that. That means I take 0 times 1 plus, I'm using the first equation, plus 1 times 0, my y value, plus 0 times 1. Well, that's 0 plus 0 plus 0. That's going to give me a 0, which matches with that. So our first equation worked. Let's try the second one. The second one says that 0 times 1 plus 0 times 0 plus 2 times 1 should give me, let's see, that's 0 plus that's 2, matches again. So we're 2 for 2. Can we be 3 for 3? Let's try. 2 times 1 plus 0 times, oops, no, plus, using my third equation, plus 2 times 0 plus 2 times 1. Well, that's 2. That's still 2 plus 2 more. That's 4, which matches there. Our solution graphically worked. It's correct. Wonderful. Let's take a look now at the column picture. Take a look at the column picture. So I've got this nice space here. Let's look at columns. Column. All right, a column picture. There. Column picture. All right, so let's do the same process. I'm going to draw our, that's kind of a wavy Z. Let's fix that. Okay, there's my Z-axis. I'll label it. I'm going to draw on this way. My Y. And down to the left, there's X, Y, and then let's mark these off. I'm going to use an eraser width. Maybe you have an eraser. Use that one. That should work as well. 2. Let's try this. Let's go 1, 2. Oh, I can go 3. Let's go upwards. 1, 2. Oh, I didn't have quite room for 3. 3 would be right there at the top. So let's do that. And then here's my Y tick marks. And X tick marks. Oops, that should be at an angle parallel to my Y axis. Okay, I think we're ready. Oh, you know what? Check it. Look at this. I wasn't thinking very well, was I? Notice that Z, my B value, is going to go up to a 4 in the Z's. Well, we can fix that. It looks really fixable. How about we just make our Z-axis at a different scale, and there it is. There's Z is 4. 1, 2, 3, 4. Okay, I think we're set. Z is 4. Here we go. Our first, now we're going to graph U. U is this vector right here, 0, 0, 2. So let's graph 0, 0, 2. 0, 0, 2. Oh, yeah. I think 0, 0, 2 is probably a purple color, if ever there's been one. So X is 0, so I stay here. Y is 0, and then Z is 2. So that's going to give me, the vector U right here. So that is my arrow. That's the vector U. Now let's take a look. Our next vector, V, is, let's come back over here. V is 1, 0, 2. 1, 0, 2. Let's try a pink one for V, 1, 0, 2. Okay, so that means I move 1 unit on X, 0 for Y, so I don't go to the right or left. So 1, 0, and then up to 2. Oh, okay. Well, to get to 2, that means I'm going to need 2. Something like that. Okay, there we go. So 1, 0, 2, that's right here. That's the vector There is my vector v. And let's see, I've got two more to go. I've got two more. Let's use blue, 0, 0, 2. X is 0, so we don't move down on the x. Y is 0, so we don't move this way. Did I make a mistake? Oh, I did make a mistake. Let's fix that. Let's fix that. My actual UVW, the vector W isn't 0, 0, 2. It's 0, 2, 2. Oh my gosh. You've been watching that for a long time. I apologize. It's probably driving you crazy. Fortunately, I got it correct here, though. Okay, 0, 2, 2. 0. So x is 0, y is 2. That puts me here. Z is 2. In other words, I need to rise 2 units off of y. So we go right up and right here. So, pink, purple, oh, blue. You said this is a blue vector. Okay. And finally, that's the vector W. We have one more. That's the vector B, 0, 2, and 4. Okay, so x is 0, y is 2, z is 4 this time. Well, 4 is way up here. 4 it's right there. So let's graph this. The vector B is going to be right here. Okay, there's B. Now, something really interesting is happening here. So I don't want to jump to the solution. I'd rather kind of capture the moment. And here's what that moment is that's so important. First, I'm going to fix my screen. What is so interesting here? A few things. Notice this. The vector u is right on the z-axis. The vector w, it's in the yz plane. I'm going to flip that. It's an element of the yz plane. What else do we have? What about b? b has an x value of 0 also. So b is also in the yz plane. Now, look at this. If I'm in the yz plane, and I take a vector v, well, where is v? V has a y value of 0. V is this. It's 1, 0, 2. Y is 0 here. So V is in the xz plane. In other words, if I take u and w and I add v, I'm going to take the result of u and w, which is, say it's flat on the board, and I'm going to move it out. Or if v was negative, I would be moving it back behind the board. So what does that tell us? It tells us I don't think we want v, because v would, if we add u and v, we stay in the yz plane. As soon as we add v, we can get all of the three-dimensional space. This is what we want. What we want then, I think, is it would be looking for the right chart. It would be really handy if we had a vector that would take us 2 units from W straight up to B. And do we have that? We do. It's U. It's right there. It's this. That's right. That's the answer. So in other words, what did we do? How did we get U, V, and W to B? Well, we took one W. We didn't need any V's, and we needed one U. And there is our answer. Our answer was 1 U plus 0 V's plus 1 W. In other words, the matrix A times the vector solution 1, 0, 1. And as expected, those scalars match the solution that we got from our row picture. And that is the visual of the row picture and the column picture. Thanks for watching.